This video is the third installment in complex fractions. This video is going to basically deal with complex fractions that have multiple fractions in the numerator and then again multiple fractions in the denominator. We'll deal with some variables down the road in this particular video as well. So we talked about in the last couple of videos complex fractions, right? It's a fraction dividing by some other fractions. Well, if you look at this particular problem, we have multiple fractions in the numerator here, and we have multiple fractions in the denominator here. And then our divide sign is right there, okay? So what I want to do is I want to evaluate it to see what I end up with. So let's figure out how to do it. Again, if we recall from previous videos and previous parts of this particular section, I want to find the common denominator. I want to find the number that all my denominators can go into. So this is there. Okay. So my denominators are 7, 3, 16, and 7. What number can I get that multiplies, or that all of these numbers will go into? Okay, so there's a couple different ways you can do this. One is you can just multiply them all, 16 times 7 times 7 times 3. I'm not going to do that because that number is going to be really large. But what you can also do is, because these two 7s are the same, I only need to multiply by one of them. So if I multiply 16 times 7 times 3, I get my common denominator, which is 336. So all of these now are 336. And now I want to find the numerator that goes above those 336s. How do I do that? Well, if I look at this 7, what did I multiply 7 by to get 336? Well, I multiplied by 16 and 3. So if I take this 7, I multiply by 16 and 3. Okay, because down here, this is my 7, and what are the other two numbers that give me 336? 3 and 16. That's how you're going to do it all. Well, what is 16 times 3? That's 48. So this 2 times 48 is now 96. Okay, now the next thing, we're going to multiply this 3 here by what to get to 336? Well, if I come down to my bottom there, this is my 3. What did I multiply? I multiplied by 16 and 7. So if I multiply by 16 and 7 to that 4, I get 448. How did I get from this 16 to this 336? Again, if you come down, here's my 16. What is left? The 7 and the 3. So I have to multiply this by 7 and 3. So if I take 3 times that 7 times that 3, I get 63. And then this 7 here, I multiplied by a 16 and a 3. So if I take the top 16 times the new 16 and the 3, I get 768. Now I can kind of go from there and use my shortcut that I've been talking about. So since my denominators are all the same now, I can take 96 minus 448, divide by 63 minus 7, 68. So now I subtract the top. 96 minus 448 is negative 352. Divided by 63 minus 768 is negative 705. We might or might not be done. We have to kind of see from there. So what do I know right now? I know that I have a negative on top and a negative on the bottom, so they make a positive number. Then I need to see if I can divide them by 2 or 3 or 4 or 5 and so on. And if you keep going through all your numbers, you'll realize that you can't divide them by anything. So that means our answer is going to be 352 over 705. Let's look at this particular problem. I have 4 denominators, the 2, the 18, the 4, and the 36. I need to find a number that all of those can go into. So if we know multiplication, okay, this one's going to be easier than if we don't. Most of these will be easier if you know multiplication, like if we do really well with it. Okay, if we don't do well, then we're going to struggle. If I look at the 2, 2 goes into 36. If I look at the 18, it goes into 36. If I look at the 4, it goes into 36. And of course, 36 goes into itself. So that means my denominator is 36. If you don't know that, then you can multiply them together, and you can get some ridiculously huge number. That's okay. You'll just have to simplify. If you want to use 72 or 108 or 144, that's okay. You just have to simplify further. So now this 2 here, I had to multiply by 18. So that gives me 18 on top of that one. This 18, I had to multiply by 2. So this gives me 2, because 2 times 1 is 2. This 4, I had to multiply by 9. So 25 times 9 is 225. And then this 36 times 1, right? Because it's the same number, so this means 25 stays there. So now, again, all my denominators are the same. So my denominators can now just kick away. So I get 18 plus 2 over 225 minus 25, which is 20 over 200, which hopefully you know that you can divide them by 2 or 5 or 4 or 10 or 20. 20 is the biggest one. So if I divide them both by 20, I get 1 over 10. And that is your final answer for this one. Go ahead and pause the video to try to figure this one out using the same problems or the same steps as the last one. Okay, let's look at this one. Well, so I need to find a number that all of these can go into, the 9s and then a 12 and the 5. So let's see what I get. Again, multiplication skills will come in handy. So there's a couple different ways we can do this. One is I can multiply 12 times 5 to get 60, and then I can multiply by 9 to get 540. You can very well do that. I'm not going to. I'm going to kind of show you another way to do it. So let's kind of go through this and see. The reason why I'm not going to choose 12 and 5 to do first, I'm going to choose 12 and 9. The reason why I'm going to choose those two is because if you think about it, there's a 3 in common between those two, so it's going to make my numbers even smaller. So if I look at 12 and 9, what number can both of those numbers go into that's pretty small? So both of these numbers, 12 and 9, can go into 36. Okay? Then I have the 5 there, so I then have to multiply this by 5 to get 180. So that is my common denominator. There's a lot of tricks with these finding common denominators. Again, if you struggle and you don't want to take too much time to figure it out, then just multiply them all together. If you have multiple numbers that are the same, like these two 9s, then only multiply by one of them. Don't do both of them, because then your number will be even larger. So now I need to write a new numerator to reflect my new denominator. I have to multiply this 5 by 20, this 4 by 20. I have to multiply this 12 by 15. I have to multiply this 5 by 36. So when I do that, I get 100, I get 80, I get 15 times 5 is 75, and then 36 times 1 is 36. So now let's add my numbers in my numerators. 100 plus 80 divided by 75 plus 36. This denominator is now 111. My numerator is 180. Now, if we know anything about divisibility rules and dividing by 3, I can divide both of these by 3. That's 60. And that denominator is 37. And I can't go any further than that because 37 is a prime number, so this means I'm done. So that's what you should have gotten if you did this particular problem. Now looking at this problem, we see that we have, again, kind of a lot more numbers just like we had in the last 3, but now I have variables. So I need to change all of my fractions, my denominators, to the same number. So let's see if we can determine what that is. Well, I have a 9, an x, a a 25, and a 3. Well, like we said on the last one, I can very well multiply them all and find out a big number. And if you do that, you're going to get like 675 or something like that. Well, that number doesn't have to be that big, okay? So let's go through some strategies to figure out if it's a smaller number. So if I take 3 times 25, that's 75, and then I multiply by that 9, that's when I get the 675. But I don't want to do that. I want to see if I can get a smaller number. So take numbers that we know that have stuff in common. So those, what do they have in common? Well, they have a 3, okay? So they have a 3, okay? That means that this 3 doesn't actually have to, I don't have to use it, okay? That 3 I don't actually have to use. So I have to just take 25 times 9, because this 3 here is in that 9. So 25 times 9 is 225. So that makes 225 my common denominator. Now, how did I get 225? Again, I said it was 25 times 9, okay? Or, remember 9 can be 3 times 3. Okay? Now, I have an x here that I didn't touch yet. Remember I also talked about common denominators in previous sections with variables. I said because I need the highest degree of the variable. So I only have one x, so that means I need one x in my common denominator. How did I go from 9 to 225x? Well, I multiplied by 25x. So 25 times 25x is 625x. How did I go from x to 225x? I multiplied by 225. So 225 times 5 is 1125. Now, how did I go from 3 to 225x? Well, I multiplied by 75. How did I get 75? If this is the 3 that I'm talking about, these are the numbers that give me 225. So that's 75. So 75 times the numerator, which is 75x squared. And then this 225 times 9. So this is also 9x squared. Now let's kind of finish our problem. So my numerator is going to be 625x minus 1125 over 75x squared plus 9x squared. My numerator stays the same because I can't simplify it right now. Like I can't combine like terms. My denominator I can combine like terms, so I get 84x squared. Now if I look at my numerator, I can definitely take out a 25, maybe even bigger numbers from there. I can definitely actually take out 125 if you actually think about it. But the denominator, I can't take out a number that's divisible by 5, okay, because 5 doesn't go into 84. So because of that fact, I cannot do anything else, therefore I'm done. Now if you wanted to factor out the numerator and make it smaller, this would be one possible way. You would get 125 times 5x minus 9. Okay, that would be a way to do that. I would leave it as 625. I would leave it as 625x minus 1125, but you can factor it out. That's okay. Let's look at this particular problem here. I want to find a common denominator, like always, right? And if I look, my denominators are 3, 4, 5, and m. Well, we know an m is going to be in my denominator. Like, that's a given. But what's my number that goes with it? Well, I have 3, 4, and 5. In previous problems, I told you to potentially you can multiply them together and you can get a number that they all go into. But I also said, instead of getting large numbers, try to use numbers that are kind of in common already. But this 3 doesn't go into the 4, which doesn't go into the 5. So none of these numbers can go into it itself or use them as factors, so I have to multiply them all together on this one. So 5 times 4 times 3 is 60. So 60 is the coefficient of my m. So now what did I multiply 4 to get 60m? I multiplied by 15m. So 15 times 15 is 225m. What did I multiply 3 by to get 60m? I multiplied by 20m, so that gives me 100m. What did I multiply 5 by to get 60m? I multiplied by 12m, so 12m times 4 is 48m. Now what did I multiply m by? I multiplied by 60. So 60 times 16 is 960. Now my denominators are all the same, so I get 225m minus 100m over 48m plus 960. Combined terms up top, I get 125m over 48m plus 960. Try to factor out the numerator, the denominator, stuff like that. If you actually want to try to factor the denominator, you can actually take out a 48 and you get m plus 20. Okay, but again, 48 and 125 have nothing in common. One's divisible by 2's, but none of the other one's divisible by 5, and so on. So you actually can't divide by anything. So your answer is this, or if you wanted to put the factored form in its place, that's also acceptable. Go ahead and try this particular problem here. Again, pause the video and then press play when you guys get done. So common denominator. This one's a little easy because I have x's and then a 16, so I know that I have a 16x. This one's really simple there to find it. You don't have big numbers, it's not that bad. So I need to find what times that would be 16x, so I gotta multiply by 16, so that's 256. So times 16, that's 80. Times 16, that's 48. Times x, that's 5x. Denominators are the same, so 256 plus 80 over 48 plus 5x. Simplify on top, 256 plus 80 is 336 over 48 plus 5x. Now, how can I tell if I'm done on this one? This 5 is not divisible by anything other than 1 or 5. Therefore, none of the other numbers are divisible by 5. So because of that fact, I'm done. This concludes this video, which is complex fractions. And if you look at them, they look a little bit more complicated. We're still dealing with monomials in the denominators of the fractions, but we have more fractions instead of just, single ones. We have multiple ones in the denominator and in the numerator. So if you need help with other particular problems, please watch those videos to get help.